Potential smoking gun signature of supermassive dark stars found in JWST data by Colgate University. Do you think at Colgate University it's banned to brush your teeth with Crest and you have to use Colgate toothpaste? Do you think they hear that joke a lot? So the first stars, oh, actually, here, let me read the thing here. This image taken by James Webb Space Telescope highlights the region, which y'all should know, by the way, highlights the region of study by the JWST Advanced Deep Extragalactic Survey JADES. This area is in and around the Hubble Space Telescope's ultra deep field, and our background image is also part of this. Our background image is the JADES. Just one image of it, though. But yeah, really pretty, really cool stuff. So the first stars in the universe formed out of pristine hydrogen and helium clouds in the first few 100 million years after the Big Bang. New JWST observations reveal that some of the first stars in the universe could have been very different from regular nuclear fusion powered stars, which have been observed and cataloged by astronomers for millennia. So a recent study by a whole bunch of awesome people all over the place at different universities identifies 4 extremely different objects, distant objects, that are consistent both from the point of view of their observed spectra and morphology while being supermassive dark stars. Their paper is published in the journal Proceedings of the National Academy of Sciences. Supermassive dark stars are extremely bright, giant, yet puffy clouds made primarily out of hydrogen and helium, which are supported against gravitational collapse by the minute amounts of self-annihilating dark matter inside them. Supermassive dark stars and their black hole remnants could be the key to solving 2 recent astronomical puzzles. The larger than expected, extremely bright yet compact, very distant galaxies observed with JWST. Those were like the universe-breaking galaxies you maybe heard of like a year or 2 ago. And the origin of the supermassive black holes powering the most distant quasars observed. Freeze developed the original theory behind dark stars with Doug and Paolo, and they published their first paper in the theory of the physical review letters in 2008. In that paper, they envisioned how such dark stars might have led to supermassive black holes in the early universe. In a 2010 paper, some other people identified 2 mechanisms via which dark stars can grow and become supermassive, and predicted that they could seed the supermassive black holes powering many of the most distant quasars in the universe. This is interesting. Although dark matter makes up about 25% of the universe, its nature has eluded scientists. It is now widely believed that dark matter consists of a new type of elementary particle yet to be observed or detected. While the hunt to detect such particles has been on for a few decades, no conclusive evidence has been found yet. Among the leading candidates for dark matter are weakly interacting massive particles, WIMPs. When they collide, these particles would theoretically annihilate themselves, depositing heat into collapsing clouds of hydrogen and converting them into brightly shining stars. The conditions for the formation of dark stars were just right a few 100 million years after the Big Bang, and at the center of dark matter halos. This is when and where the first stars in the universe are expected to have formed. For the first time, we've identified spectroscopic supermassive dark star candidates in JWST, including the earliest objects at redshift 14. That might be in our background image they're talking about, by the way, y'all. That's really cool. Including the earliest objects at redshift 14, only 300 million years after the Big Bang. Weighing 1,000,000 times as much as the sun, such early dark stars are important not only in teaching us about dark matter, but also as precursors to the early supermassive black holes seen in JWST that are otherwise so difficult to explain. That would be cool. Here's some graphs. It's a little bright, but showing some of the 4 supermassive dark star spectral candidates. I feel like this is like big breaking news today, actually. In a 2023 PNAS study, the first supermassive dark star candidates, JADES GSZ Z13 0, Z12 0, Z11 0, were identified using photometric data from JWST's NIRCam instrument. Since then, spectra from JWST's NIRSpec instrument have become available for those and a few other extremely distant objects. The team, which now also includes Shafat, analyzes the spectra and morphology of 4 of the most distant objects ever observed, including 2 candidates from the 2023 study, Z14-0 and Z14-1. They also found that each of them is consistent with a supermassive dark star interpretation. That's cool. Yeah, I think these are like the furthest and most distant. Oh yeah, it does say some of the most distant objects. I was like, these are the most distant objects, like galaxies and stuff that we've observed. This is cool. This is really cool. JADES GSZ 14-1 is not resolved, meaning It is consistent with a point source, such as a very distant supermassive star would be. The other three are extremely compact and can be modeled by supermassive dark stars powering a nebula, ionized hydrogen and helium gas surrounding the star. Each of the 4 objects analyzed in the study is also consistent with the galaxy interpretation as shown in the literature. Dark stars have a smoking gun signature, an absorption feature of like 1640 angstrom due to the large amounts of slightly ionized helium in their atmospheres. And in fact, one of the 4 objects analyzed shows this feature. One of the most exciting moments during this research was when we found the 1640 angstrom absorption dip in the spectrum of JADE's GSZ140. While the signal-to-noise ratio of this feature is relatively low, it is for the first time that we found a smoking gun signature of a dark star, which in and of itself is remarkable. This is really cool. Astronomers using Atacama large millimeter submillimeter ray ALMA measured the spectrum of the same object, revealing the presence of oxygen via a nebular emission line. Researchers said that if both spectral features are confirmed, the object cannot be an isolated dark star, but rather may be a dark star embedded in a metal-rich environment. This could be the outcome of a merger where a dark matter halo hosting a dark star merges with a galaxy. Alternatively, dark stars and regular stars could have formed in the same host halo, as the researchers now realize it is possible. This is cool. The identification of supermassive dark stars would open up the possibility of learning about dark matter particle based on the observed property of those objects, and would establish a new field of astronomy, the study of dark matter powered stars. This could be huge if confirmed, but either way, they still have like a potential candidate for it. Like it said, it's the first time they found a, smoking gun signature of that. So I'm kind of curious to see how this goes over time. Curious to see how like peer review and other scientists in this field, when they like check this out, what their thoughts on it are. That was a cool one. I posted that in Discord.